Welcome back to the New Player Career Build Series. This is episode number 3, and so in the last episode we did our first rescue. So put together a boat using my hull from my hull tutorial, and went out and did our first rescue and brought the people to the hospital. And so that's kind of getting you going in the game, starting to see the first mission and how that's going. And so the next thing that most of us, especially those of us who build ourselves, will need to do is modify and improve those vehicles. So that's a big part of the game. Go out there, test them, do some missions, realize what your vehicle needs, and improve. And so we're going to go ahead and start doing that in this episode. So let's go to the workbench here, and we'll find our boat. So here's our boat, and so let's go ahead and just give it a quick run, and we'll kind of recap on how it's behaving and how we can improve it. So the physics in game is not perfectly realistic to life. Now we can complain about that, or we can use all the great tools we have and the knowledge we can gain to improve upon it and make things work the way we want. One of the benefits of the game not being completely realistic to real life is you can make some really cool fantasy stuff like airships, infinite generators, stuff like that. And so there are pluses and minuses to it. One thing is boats don't act perfectly correct, but we can use some realistic physics, some realistic mechanics to try to get the craft that we make to behave a little bit more realistically and predictable. So let's go ahead and start up. All right, so as we increase the thrust of the boat, you'll notice that the bow comes shooting up. Now, this is pretty realistic actually to real life, and what you'll have in boats is, especially of this size, are trim tabs. And so what they are is a couple little fins in the back of the boat, and they go down to help push the stern up. So we have to ask the question, why is the bow coming up? The bow is coming up because the propellers, as you can see, they are below the center of gravity. So if we go ahead and we bring it back to the workbench, we can see this in the editor. So if we look, our center of gravity is indicated by this pink square here. If we come up right against it, you see it's just under the water line here. And so the center of thrust is here at the propellers. So the propellers are pushing, the center of gravity is here. So what this is, think of this as your pivot point. So if this was our pivot point, as we push the bottom, it's going to tip the bow up. Now in real life, you'll often see that the propellers are angled down. Now we could do that, but it is not a great idea. The better way to do this is to control it with fins. And so what we'll start to do is put some control fins in here, and what they will do is act as trim tabs. And so let me show you some pictures of some real trim tabs. So here's what a trim tab looks like IRL. So you have a hinge, you have a plate, and you have an actuator, something to move that trim tab and push it down into the water or bring it back up. So as you can see, we have a flat trim tab here, and just as with our boat, again, some people will think this is not realistic. This is realistic. Again, your center of thrust is below your center of gravity, and especially in this boat, it has to be. The propeller is below the boat altogether. And so because this is below, it's going to push up and it's going to raise our bow up. Well, what you do is you push the trim tab down. So as you're pushing, as the thrust is pushing, it's still trying to push the bow up. The resistance of the water is pushing up the tab and raising the stern. So we're going to want to do this ourselves. So here we are in the editor, and let's go ahead and work on this. So ideally, it's good to get them right at the propellers if we can, and so we don't have a ton of space here, but we should be able to do it fine. So we need to find a place for these fins, and so let's search for fin. These have your best efficiency for size. These are pretty small, these fins. And so what these are going to do is this is going to act like a trim tab at a boat or a control surface in a plane. They actually can work as both for both areas. And so one thing we can do is we can actually learn a trick really right now that's kind of cool. So this is important to the game. You can do this, and this will actually be kind of a cool tip to be able to move things around where you want them. So let's first grab using the select tool. So select tool, hold down control and click on the propeller, and we'll cut it and we'll move it up back here for now. And we'll do the same on this side. All right, we'll turn on symmetry after I paste this. And we'll go ahead and we'll start working. So what I'm going to do is just take a block, and I'm going to make it pink because that just tells me I need to delete it. So right there is where the end of the propeller right here is. Now if we take the fin again, you'll notice it will not allow us to paste it here. We get that red brick, that red block there. But we can do it here. All right, and so what we want to do here is paste them here. And so this will let us put them right here, and then we can move it back in. So you can actually have parts that are floating and not actually touching. This will look like it's touching, but you can have parts float in the game and still be attached, which is kind of a cool feature. So what we're going to use in the back here is an altimeter system. And so what this is going to do is it's going to say, hey, I want my stern at a certain altitude. And these fins are then going to articulate to maintain our stern at that altitude. And we'll do a different system on the bow, and I'll tell you why later. So first thing we need to know is as the altimeter goes up, it's going to increase in number. And we want to keep this at a certain height. And so what we want to do is as the altimeter is increasing, we want this to automatically increase the fins so that they go the opposite direction. So as our stern is raising up out of the water, we want it to be pulled back down in the water. As it's being pulled down too far in the water, we want it to go back up into the water. All right, so the orientation of these matters. So what we want to do is we want to put, if you look here, it has two arrows. One is hollow and one is solid. So we need to understand how this is going to work. So when we feed this a positive number, this is going to come down, raising up the stern. So if we put it this way, as the altimeter increases, as the number goes up, it's going to push the fin down, making it come up even more. That's the opposite of what we want. So what we want to do is, let's go ahead and grab the fin, and we're going to put it like this, and then we're going to press the U key. And you'll notice it swaps it. So we can press U, we can press I, and we can press O. O will swap it, in this case, forward back, as you can see. I will swap it left right, and then the U key will swap it up down like so. So we want to put that like this with the solid arrow on the top. And so as the altitude is increasing, these fins are going to tip down, which is going to pull the stern down. So as it goes up too high, it's going to correct it down. So we're going to go and we'll click on that. Then we're going to come over here and we're going to do it like that. So this, as you can see, we have double finnage on there. Now what we can do is we can grab both of these, we'll cut them, and we'll drag them back in right. They're off-centered a little. Let me fix one of them. And I'm just going to show you here how we can drag both of them at once. So let's go ahead and shift, and we'll grab both of them, we'll cut them, and we'll put them in where the pink blocks are. All right, we'll paste them. And if we notice, our fins are still there. Our fins are still attached to the main body. Our fins are part of this red body still. And that's because we used a block there and we told it, hey, we want these fins to be attached to this. So you notice how it wouldn't allow me to connect it there. But because I put blocks in, it let me quote unquote cheat it and stick it in there. All right, so now those are in there. Now we have them on the port side and we have them on the starboard side. Now this is one of the reasons I like to use altimeters. So what I want to do is I want to keep a certain amount of my boat always in the water. The more of the boat that comes out of the water, the faster we can go, but we will start to impart some stability issues. So I want to look at this boat and I want to think about where I want this boat to be in the water. Personally, I always want this part in the water here. I don't want it to come up any higher than here. So I want the water to be right here. So if we look at the view here, when this rises up out of the water, it's called coming up on plane. When I come up on plane, I do not want to come out of the water more than there. That is where I want to be. So we're going to go ahead and we will set our altimeter so that it's right there. So if we look and we say, okay, it's right here, this is it right here. And so what we can do is take ALT for altimeter. You'll notice they pop up, and we want two of them. So there's one there on port and one on starboard. All right, so that is going to tell us this is our 0 point. That is where we want it up out of the water. And so really simply to start with, all we're going to do is take this altimeter and we're going to drag it to the two fins. That is it. Really super simple. And one of the reasons I like this is it's super simple. The other reason is this. I want my boat to behave naturally. If I make it replicate what happens in real life, we're going to get realistic results and predictable results. And so what happens in real life is this. Is as the back of the boat comes out of the water, well, the force of gravity is working on it to pull it back down. So this is going to always try to keep it at that 0 point. The issue is this. If we did that in the front, what would happen is, as we get a big wave, if we did on the bow, as we come up to a big wave, we're going to crash right through it because we're always going to stay at zero altitude, and the wave is going to go up over zero altitude. We're going to crash through the wave. So we're going to do a different system on the bow, but for now, this is what we want in the stern. This is going to always try to keep the stern at an altitude of zero. Now, you notice there are two. Why did I do two? Because we're not just going to be accounting for pitch. We're also going to be accounting for roll. This is going to give us roll stability. So if this altimeter were to go higher than this altimeter, so say this one is up here and this one is down here, well, that means we're banking rolling to the right. This side's going to want to bring us down, and this side's going to want to bring us up. So this gives us both pitch stability and roll stability. So let's go ahead and hook up the electricity. So we'll hook these up. All right. And we're going to go ahead and hook it up to the relay. Now, again, I like having a relay, and one of the reasons is this. Let's say that we left this out in the world, and we went and did a rescue, and we didn't shut off our relay. What's going to happen? Well, the whole time we're bobbing up and down in the waves, these fins are going to be moving, using up electricity. By hooking them to the relay, when we get off our boat, we can shut the power off, and it will stop doing that, and it will naturally just bob in the water. So these are now connected. Let's go ahead and go. So if we remember last time, the bow came shooting up. It may still come up a little bit. It probably will because we do not have any stability control in the bow yet. But we're just going to have it in the stern here. But it should help. All right, so we're started up. Let's go. And I'll go in third person so you can see. So look at that. The bow came up a little bit, but look at how much better that is. We don't have that bow shooting up into the sky anymore. And this is good for a number of reasons. If you remember last time, the bow was way up here. We couldn't see at all. And so now we can see straight ahead. We can see our rescues. We're so much flatter than we were before. Let's take a turn. So remember, I said this is also going to take care of roll stability. So as we turn, look at how nice and flat we are. Now, we may not want it this flat, but we can get it this flat, as you can see. So this is giving us a nice, flat, stable platform to operate. All right, so look at how nice and stable that is. Now, we may not even need to go into the bow in this one. We probably will at some point. But let's go ahead and we'll throw on some wind. So here's 63% wind. Let's go into the wind. That's the most extreme case. And we'll see how well this behaves. So notice how it's behaving nicely. It's handling the waves pretty nicely. Just with that very super simple stability system. All right, good. So I'm going to zero our thrust. We'll go back in and we'll zero out the wind. This is going to be a problem, though. Watch this. When I go into reverse, the fins are going to act opposite to what they should be doing, right? The fins are all set up to be going forward. When I start to go into reverse here, watch what's happening to the stern. The stern is trying to be pulled down, and notice it's actually pitching the stern down. If you look at our fins are turning the opposite direction to where they should be turning for going in reverse. And so what we need to do is we need to invert the fins when we go in reverse because they need to be opposite when we're going the opposite direction. So let's go ahead into the workbench. And so we already have a linear speed sensor here, but we need to make a change. So linear speed will tell us our speed in a linear direction. It's currently on absolute. What absolute is going to do is if I go 10 meters per second forward, it's going to read 10. If I go 10 meters per second backwards, it's going to read 10. I want to switch this to directional. Now, what that means is if I go 10 meters per second forward, it's going to read 10. If I go 10 meters per second backwards, it's going to read negative 10. So that's going to tell me directionally which way I'm going. So this is a way we can trigger the system to tell our boat, hey, I'm going backwards. I want you to make sure that the fins are reversed. So we'll go ahead and we'll start with a microcontroller. So I typed in blank to get a blank microcontroller. And I'm going to put this here, and we'll call it something. So we'll call it stability. All right, system. All right, stability system. And so let's go ahead and we'll put some nodes in here. So we need to have, we'll start with 2 nodes here. So this is going to be number input. This is going to be the port altimeter. And this is going to be the starboard altimeter. All right, so we have the port and starboard altimeter. Next thing we need to have the port and starboard fins. So we're going to do number output, port fins, number output, star fins. All right, we also need one more here. This is going to be number input. This is going to be linear speed. All right, and so let's go ahead in here. So we're going to grab these. We'll move them down a little bit, and we'll start putting our inputs and our outputs. All right, and so let's go ahead and look at this. So we have port altimeter, starboard altimeter, and we have the linear speed. The only thing we need to do here is invert it. So we're going to go function, and we're going to go -x. And we'll do another one. Actually, we'll wait. We'll build this microcontroller out, then I'll copy it for the starboard because they're going to be the same. So we have a -x there. And next thing we need is a numerical switch box. All right. And so what we do with the numerical switch box is we feed the port altimeter into here. That's for going forward. When we're going in reverse, we want to take a -x, an inverted signal. So again, if it's going to give us a 1, which will be the fin all the way in one direction, when we go backwards, it will give us a -1 going backwards, and that will invert our fins. So pretty simple there. That's going to go out to port fins. And then what we want to do is we want to figure out how to trigger it. So let's go ahead and we'll do a less than. So if our speed is less than 0, i.e. we're going in reverse, it will trigger this switch. So if we're in reverse, it's going to make us go backwards. So if we read it, this is the off value. And when we're backwards, we're turning it on. This is the on value, negative. So this will invert our fins. And you'll end up doing a lot of inversion. So then we're going to copy that, Control-CV. And we'll grab it and we'll stick it right here. And so we'll put in the star. We'll plug this into the inversion there. This will get plugged in to the switch there. Starboard will come down here. And that plugs in. So now when we go in reverse, it's going to invert the fins, make them do the opposite, which will fix this problem. So my reverse is not powerful presently enough. You see how slowly we go in reverse? So see how it's a -5? That means we are going 5 RPS in reverse. That's not enough power for us to get going in reverse. So let's go a -10. That will give us more power. All right, so next thing we need to do is we actually need to hook it up. So let's go ahead and do that. So right here we have our port fins. So let's hook that up. Here we have our starboard fins. Let's hook those up. Now we're going to take the port altimeter and we'll find the port altimeter. Starboard altimeter will go to the starboard altimeter right there. And then linear speed will go here. All right, so let's go ahead and give this new one a run. So let's start up. And we'll go forwards. So again, you notice it sits nice and flat. Let's press the spacebar to 0 our thrust. And we'll go in reverse. And as you can see, it's raising up our stern, which isn't the end of the world. We can fix that with the front one. So what it's doing is that is giving us extra lift. All right, so we're going to go ahead and we're going to fix that with a bow stability. So go wedge here, like so. We'll make this exposed. And so we'll go ahead and let's do 3 just to be certain. Actually, let's do 2. So what we'll do is we'll put a block here and we'll do another spot here. And we'll make this stick out like so. So this is, I don't like them sticking out. I tend to make it flush mount. I'll show you XMLing later. And so what we want to do here is, this is pretty easy to tell, is we're going to grab these fins here and we're going to stick them there. And usually, I believe, if memory serves, they're opposite of the stern. So as you can see, we have the hollows up top and the solids in the bottom. Now, we're going to control this system differently. We're not going to do an altimeter. And I said before, why not? And I'll reiterate, if we made that an altimeter, what would happen is this. The boat would always try to stay at 0, 0. And if a wave went up above 0, it's going to cause us to crash through the wave. You don't crash through a wave IRL, really. You end up going up and over it, especially in a boat this small. So you're going to go up and over the wave, and we want that. So as you go up the wave, what we're going to do is we're going to have the front fins, and they're going to work with a tilt sensor. And what that's going to do is it's going to tell our boat to stay at 0 tilt. So as we go up the wave, it's going to try to pull our bow down. That's going to simulate gravity, right? As you go up the wave, the gravity is still pulling you down. So that's simulating gravity. The stern is going to still try to pull itself down. So what's going to happen is as we go up the wave on the side, it's going to act very naturally. Gravity is going to push us against the wave. Our fins are going to push us against the wave. As we go over the crest of the wave, the bow is going to pull itself down. The stern is also going to try to stay down, and it's going to cause us to slide down the wave nicely. If we did this tilt sensor in the back, it would cause the bow to come up out of the water, and it would be very unrealistic. And we would ride down the wave very flat and it would not look right. So this is going to look very realistic. So we have our two fins there, and we're going to go ahead and we're just going to add it to the stability system. So let's go ahead in the stability system here and we'll add some nodes. All right, good. So what we need here is we're going to add a node, and this will be bow fins. Number, output, bow fins. Okay, good. Next thing we need to do here is we need to bring in a tilt sensor. Number, input, tilt. All right, so what this is going to do is, again, the bow is just going to work with the pitch. It's going to try to keep us evenly pitched. All right, so let's go ahead and grab these nodes and we'll move them down here. All right, so we're going to read in our tilt sensor and we're going to use a PID. All right, and this is eventually going to go to bow fins. All right, and how are we going to trigger this? So what I want to do is I only want that PID running when we're moving. So what we're going to do is we have linear speed, and I'm going to take a knot. All right, and so we're going to put a knot there, and then we're going to take a threshold, and we're going to put in a 0. So when our speed is not 0, i.e. we're moving, it's going to turn on the PID that will get us, this PID will turn on, and that will start to work this stability system. All right, pretty simple. So when we're not going 0, i.e. we're moving, it's going to start up the PID. All right, so tilt sensor. So our set point, this is where we want to be. We want to be at 0. If we don't fill in the node, it will read 0. So we don't even need to put anything in here. That is 0. Then we put in tilt. All right, next thing we want to do is I'm going to take a property number, and this makes it so that I can adjust it outside of the box. This is going to be the p-value. Bow stab, okay, for bow stability, and I'm going to put in a 50. I know 50 works well. I've tested this out with other craft. You can just go out and spend hours and hours testing. I'm using these numbers because I've already tested other craft, and I know kind of where I need to be, and each craft might need a little bit of tweaking, but we can kind of work with that. So now we have the PID in there. So the 0 for the set point, tilt goes into our process variable. My p-values here, I'm going to start with 50. We'll see if that needs change. 0 for I and D. And if we're moving, it's going to turn on our bow fins. All right. Let's do something else before I move ahead here. So this whole argument here, we can copy it. So we have the same condition here. If I'm going in reverse, I still need to invert the fins, or else it will work backwards. So I need to invert these fins. So that will plug in there like this. All right, and this will plug in there. So what will happen is, again, when we go in reverse, I want it to invert the fins. So we need to trigger that again, so we can grab this here, and that will trigger this. So this will invert the bow fins as well. All right, so now let's go ahead and hook this up. So we have the bow fins. Those get plugged. All right. We have the tilt sensor. We don't have one yet, so let's put a tilt sensor. Now, you'll see some old videos telling you, oh, you need to put this down low, you need to put this up high, you need to put this in a different, but it does not matter. This works globally. It knows where it is in relation to the horizon in the game. You do not need to put this anywhere specific, just stick it in there. But make sure the arrow is pointing forwards. That's going to give you the proper axis, because you can also turn a tilt sensor to the side for roll stability. You can also turn it vertically. You can turn it different directions. So we want it facing forwards like that, and that's going to give us our pitch stability. So we're going to go ahead and we're going to hook this up to the tilt sensor. And let's see what else we need to do. So we need to hook up electricity to these fins. I'd like to hook up like systems, so we'll hook it up to that fin there. Let's go ahead and spawn and check it out. All right, now we'll go forward. All right, and we'll look to the side here. Let me quickly just override the time of day. And so as you can see, we're riding nice and level here. Let's go ahead and add some waves. This should help us perform a little bit better in the wave. We'll go to 60%. That's pretty strong wind in game. And watch the behavior over these waves. The bow wants to stay flat the whole time. The stern always wants to stay at 0. So these waves aren't very big. Let's get some big waves in here. We might have issues with the wind if I turn it up to 100%, but we'll probably be all right. See, the wind wants to take us out a little bit, but notice, you'll see a lot of people, their boats are actively flying at 100% wind. They're doing backflips. They're doing all these things. We're going into the wind at 100% wind, which is the worst case scenario. We naturally have the bow raise over the wave. It then comes down. We're super stable here, and we're able to operate in 100% wind, no problem. All right, so perfect. So that's good. Let's go ahead and we want to test in reverse to make sure that the system inverts properly. It should, because we were going forward fine. Let's back it up. And if you notice, remember last time, our stern was coming out of the water more, right? If you remember the last time before I put this bow system in, we could see air underneath the transom. If we zoom in, you can notice, look at those front fins. They're pitching up, going backward, and that is helping to raise that bow out. Well, that's keeping us level even in reverse. So I can steer in reverse. As you notice, it's very super stable, nice and stable. We'll press the space bar, we'll go forward. The system automatically takes care of all this. And it is really super duper simple. All those numbers are working, beautiful. So this ship is working, or this boat is working really well. It works in 100% wind. You know, this could be your first day boat, and you already are way ahead of the game. You know, you already have a good stability system going here that is going to allow you to do rescues in high wind. You know, we're having no problem with that. We're stable. You can see I can see out the front before the bow was up here. So let's actually recall this and save it. And what I'm actually going to do is we'll load up the boat that we had last time, and we'll see the difference in performance. So this is the one from last episode. All right. Now let's watch the difference in performance. So let's go 6 to start. Let's go. First thing we're going to notice here, I'll go in first person. Watch the bow. Remember, we could see straight out like this. Look at that. That's what we'd have to drive around with this bow way in the air, right? It looks ridiculous. It makes it so we can't see. It's swamping the back of the boat. Start to turn. Get a little bit of turning there. A little bit more. See how it bobs around as we turn? The other, you know, our new boat is much more stable. Like, see how it's bobbing around and it's very unstable. Let's try this. 100% wind. Now that should look familiar if you've seen anything on the workshop. That's what 100% wind looks like on a lot of new players' creations. Look at this. And what do they say? The physics sucks in game, the game sucks. You'll hear this from everybody. You can easily fix this. You saw how quickly and easily we fixed that. So we have a boat that now performs beautifully in this weather. So it's not all that challenging to do. It just takes a little bit of knowledge. So now we're up and running. We have this boat. Let's go ahead and drag this one back. And again, we'll do one more test with the new one. So again, this is our new stable boat in 100% wind. And you can see that the results are night and day with a very super simple stability system. It's going to take me a second to get out of the dock there. But look at the difference. We were doing literal backflips in there. And you could imagine how frustrating this would be. This is 100% wind. You'll very rarely run into 100% wind in game. But as you can see, we have now conquered that problem of stability. So this is going to be a very important step for you. Learning how to stabilize your vehicles. This allows us to make vehicles that are unrealistic if we want some fantasy builds. This also allows us to make some very realistic builds that act in Stormworks, which is a different universe than ours, that has different physics than ours. It allows us to work in Stormworks as though it was on our planet. And so as you can see, the difference is night and day. The difference of having one boat doing backflips and the other one operating very stably. Now you can go out in 100% wind and do some rescues. We'll press the spacebar and we'll just let it sit. Now remember, the bow system is going to shut off if we're not moving. Now we are moving a little, the wind's pushing us. But notice we're nice and stable. We can go out here and we can do a rescue, no problem, in 100% wind. So, hope you guys found that helpful. I think that's a good third episode to kind of go into stability. This is where a lot of people get frustrated. They get into this problem where their boat starts doing backflips and they get very frustrated with the game. It's a pretty simple situation and it can easily be conquered. So I hope you guys found that helpful, and I'll see you in the next episode.